Okay, here I've got a couple examples that we're going to look at of finding other zeros given one of the zeros. Okay, if I have this polynomial function f of x and I'm told that 4 is a zero, well, what does that tell me? It tells me I've got a factor of x minus 4, doesn't it? And if I have a factor, that means it should divide into this. And if I divide an x cubed by an x, I would get an x squared, I get a quadratic, and I know how to solve any kind of quadratic. So let's try synthetic division. And we're going to do, remember, it's the opposite of whatever this factor is, or the zero that goes in the divisor box. And then we read off our coefficients, no missing terms, so just read them straight off and write them in our first row. Then we're going to drop our 1 and multiply, put it here and add, multiply again and add, multiply one last time and add. Looking here, I want to confirm that my remainder is 0 because this is supposed to be a factor, and it is 0, so we're good. So this is going to be x squared minus 2x plus 5. So if I wanted to, I could write f of x as the x minus 4 times that x squared minus 2x plus 5. That's a factorization for f of x. But I'm looking for 0, so I'd want to know what makes this second thing here 0. I'm not going to be able to factor that, so the only alternative I have of solving that is the quadratic formula. So that's going to be the opposite of b, so that's negative. That makes that a positive 2 up front, plus or minus the square root of b squared. Negative 2 times negative 2 is a positive 4, minus 4 times a times c, so a, it's a 1 here that's not written, and 5, over 2 times a. Simplify underneath the radical and you get a negative 16, which tells us we're going to have imaginary zeros. The square root of a negative 16 is going to be a 4i, and then I have to do my division. Now, simplifying this, I divide everything by 2, so it's 1 plus or minus 2i. Those 2's just don't cancel away and disappear. You're dividing here, so make sure that you have 1 and then your plus or minus 2i. All right, let's take a look at another one. I have x to the fourth minus 45 x squared minus 196, and we're told that 2i is a 0. Okay, well, let's think back to something that we know about imaginary zeros. If I have an imaginary zero, they always come in conjugate pairs. So if 2i is a 0, then negative 2i is a 0. So now I've got two zeros, which means I have two factors, the x minus 2i and the x minus the negative, which makes it x plus 2i. I can FOIL this out and simplify, get x squared plus 4. Right? The middle terms cancel, and negative 2i times positive 2i is a negative 4i squared, but I squared is negative 1, so that's where we get that plus 4. So this is a factor of this nice trinomial. Well, it looks like maybe that should factor. Does 4 go into 196? Yes, it goes in 49 times, so let's try that. Factoring this out, writing our two parentheses, x squared and x squared plus 4 for the first one, we know that. And then what if we tried the x squared minus a 49, because we want to get a negative 196? Well, that gives me negative 49x squared plus 4. Yes, we get our negative 45x squared. So the second factor here we can break down further, because it's the difference of squares, is x plus 7 and x minus 7. So now I've factored as much as I can, and I have the remaining zeros. The only one they gave me was the 2i, so I have determined that negative 2i, negative 7, and positive 7 are my remaining zeros.